to another video on the channel. In today's video, we're going to be taking a look at question 26 from the Physics QCAA External Exam from the 2020 year. Okay. Now, in this video, I will be explaining how to solve this question here. However, if you have any further questions about it, leave something in the comments below and I'll try my best to answer it. If you need a Physics External Exam bundle pack, the link is also in the description below. And there is a code there that takes 50% off it, and it'll only work for a couple users. If you need the full external exam, the link is also in the description below, or the playlist for it, okay? But anyway, let's get straight into it. So, question 26. A photoelectric effect experiment was conducted by shining different frequencies of light onto a plate made of an unknown metal. The graph shows the kinetic energies of the ejected photoelectrons with respect to the frequency of the incident light. And we can see we have a linear graph here. The table shows the work functions of various metals, potassium, copper, and I don't know how to pronounce the last one. Determine which metal is most likely to have the ejected photoelectrons in this experiment. Now, just to add something to this question here, you've just got to identify what the metal is, okay? So in this case here, we've got to provide a lot of reasoning for it. So in this situation here, what we've also got to understand is what we're looking at here. Now in physics, there are two graph tricks that I want everyone to use, okay? If you have a linear line, and that is y and that is x, the gradient is always y divided by x. The area under the curve is always y times by x, okay? No matter what. So in this situation here, we've actually got to understand what we're looking at here. We have a photoelectric effect, okay? Which means we have energy on the side here, which is given in electron volts, and we have the frequency, which is given in hertz, okay? Now, there are many ways you can solve this question here, okay? Some are faster than others, some require more understanding than others as well. We have a linear line here, so if I were to draw a straight line, let's see if this ruler actually works that well. Don't know how you're actually meant to adjust it though, that's the thing. Unless I'm just going to get rid of the ruler. Okay, so here if I were to draw a straight line here, now obviously do a bit better than me here, you'd actually have a ruler. So something like that. This gradient here is energy divided by frequency. Okay, now in the photoelectric effect, this is a quantum topic. Energy coming in is Planck's constant times by frequency of the light. Now here we just said the gradient is energy over frequency, which means that we actually have been given Planck's constant for the gradient. Now this Planck's constant will not be the same as the one in your book. You might actually have to calculate this one for this particular data set here, okay? So if you wanted to, you could take a coordinate here and a coordinate here, use gradient, which is rise over run, and calculate that thing there, okay? Now, remember, this is only worth 3 marks. That would be a lot of working to work out. However, you can do it that way if you want to. What we've also got to realize as well is what we're looking for here. We're looking for the work function. Now, the work function is Planck's constant times the threshold frequency. Now, the threshold frequency is actually our quote-unquote x-intercept, okay, which would be this guy here. Now, this one you could actually use the Planck's constant from the formula sheet. So I would recommend using that working rather than the gradient method. But the gradient method does work, okay, and you will get marked for it even if it's not on the marking guide, because it's any way to show which metal is correct. Now, the only thing is about this, the threshold frequency is somewhere around here. So if you pick a number somewhere around here, your working will be fine because you will have a range for which they'll accept answers for, okay? So here I'm going to say 1.3 times 10 to the 15. That's what I'm going to say for the hertz here, okay? So the 1.3 is for that, and the times the 10 to the 15 is this guy here. So I'm going to say the threshold frequency is 1.3 times 10 to the 15, okay? Now, Planck's constant, if you don't remember what Planck's constant is, it is in your data book as well. So if we go to the data book here, it is 6.626 times 10 to the negative 34. So here we'll just write that down wherever that page is. So 6.626 times 10 to the negative 34 is your Planck's constant. So here, let's work out the work function. Now, remember, this will give us the work function in joules. We'll have to convert it to electron volts. So the work function, in this case here, is 6.626 times 10 to the negative 34 times by 1.3 times 10 to the 15. And then you chuck that into your calculator. So 6.626 times 10 to the negative 34 times 1.3 times 10 to the 15. So we get, in joules, 8.61. And I'll just go 3 times 10 to the negative 19 joules. Okay. Now, to convert joules to electron volts, you need to divide by the charge of an electron. Okay. So an electron volt is energy. Okay. It's just written in terms of a different unit. So 1 electron volt is 1.6 times 10 to the negative 19. Okay. So here, if I want to convert from joules to electron volts, I need to divide by this number. So the work function in electron volts is 8.613 times 10 to the negative 19 divided by 1.6 times 10 to the negative 19. And whatever that number is going to be our thing in electron volts. So if we just chuck that in, 8.613 times 10 to the negative 19 over 1.6 times 10 to the negative 19, we get about, roughly, if my calculator is working, 5.38 EV. Now, we can see that doesn't match exactly any of the things here at all. Okay. However, it will be close to one of them. Now, in this case here, because our calculation might be off a bit, we've got to work out which one of these it's actually going to be closer to. So I would say my measurement is probably a bit off. I would say it's probably not 1.3. It might be even smaller than that for the threshold frequency. So again, that's going to depend pretty much on what we've picked here. Now, once we've gotten this guy here, we have to make a rough guess off this. So if I were to change that to a smaller number, so instead of like 1.3, like 1.1, that would then change that number, which would then change that number there, okay? Now the reason why I'm thinking about recalculating it again is because this is too big to work out between copper and this one here. So if I'm just going to change it to 1.1 in this case here, just to see if we get a number that's a bit different. So if we were to do that instead, so I'll calculate this value here, so you can see it in real time, because this might happen in the exam, because you'll have a ruler as well. So 1.1 times 10 to the negative 15. So here, in this case here, I get 7.288 times 10 to the negative 19 for joules. Now I'm just going to repeat that calculation for this value here. So 7.2886 times 10 to the negative 19 divided by 1.6 times 10 to the negative 19. There we go. So now we've gotten 4.55, which is closer to copper then. Okay. So here, this number, probably closer to copper, but it wasn't obvious because of the number we picked for the threshold frequency. Now, that's probably my fault, probably just not due to measuring, etc. However, now we definitely know it's probably going to be copper. And yeah, looking at that, 1.1 does seem roughly pretty reasonable, because it'd be a pretty steep slope roughly there. Okay. Now, the other way you could have done it is with gradients as well. You would have gotten the same answer. However, it would have been significantly longer than this. Okay. If you weren't sure on this question, you need to study the photoelectric effect a little bit more. If you had any questions about this one, leave some in the comments. If you had your questions of your own, submit it in my forum. Okay. That's in the description below. If you need the Physics External Exam Bundle Pack, the link is in the description below. Remember, there's a discount code down there. They'll only work for the first 10 users. So, get in quick. But otherwise, mate, I will see you guys in the next video.